Dear students, in today's session, let us discuss KCET 2018 physics question paper in detail. Watch full video that may help you to score more in the upcoming examination. Okay, let's get started. Let's have a look on the very first question. That is, 5 identical resistors, each of resistance R equals to 1500 ohm are connected to a 300 volt battery as shown in the circuit. The reading of the ideal ammeter is. So here in this circuit we can see 5 identical resistors are connected in parallel. Whenever the identical resistors are connected in parallel, the effective resistance, that is effective resistance, is equals to R divided by N. Here total resistances, total number of resistors are 5, you can write here 5, and this R equals to 1500. So this can be done as the effective resistance of this circuit is 300 ohm. Now the current flowing through this circuit, that is I, is equals to, we need to find out I, that is I is equals, from Ohm's law we can write I is equals to V divided by R effective resistance. Now we know that the V equals to 300 volt and effective resistance equals to 300. So the total current in the circuit is 1 ampere. This 1 ampere current is distributed equally among all these resistances. So each resistances, through each resistances, how much current will flow? That is 1 by 5 amount, because the I is equals to 1 ampere here. So here through this resistance 1 by 5, 1 by 5, here 1 by 5, 1 by 5, and again 1 by 5. The total current again it will become 1 ampere. So here through this ammeter, how much current is flowing? The 1 by 5 plus 1 by 5 plus 1 by 5. So it will become how much? 1 by 5 through this resistance, 1 by 5 through this resistance, 1 by 5 through this. Total current through this ideal ammeter is 3 by 5. So the reading of the ideal ammeter E will be 3 by 5 ampere. So that is option B is the right answer. Moving to the next question, that is, two cells of internal resistances R1 and R2 and of same EMF are connected in series across a resistor of resistance R. If the terminal potential difference across the cells of internal resistance R1 is 0, then the value of R is. Here there are two cells which are connected in series, and both the cells are having the same EMF, that is, let me consider E, and their internal resistances are R1 and R2, that is R1 and R2 here. So we know that whenever the two cells are connected in series, their effective EMF is equals to sum of their EMFs, that is E plus E, that is 2E. The effective EMF of these two cells is equals to 2E, and we know that is EMF, that is the effective EMF is equals to the current times the effective resistance. Here the effective resistance is R plus R1 plus R2. This is what the effective resistance, I times the effective resistance. We know that effective EMF is equals to 2E, and this is equals to I of R plus R1 plus R2. So we could write here I is equals to 2E divided by R plus R1 plus R2, and here the question is, if the terminal potential difference across the cells of internal resistance R1 is 0, that is, we know that the terminal potential difference V equals to E minus IR, but here we need to consider the internal resistance of the cell R1, that is, let me take this is R1. So the terminal potential difference across the cell R1 is equals to 0. So this will become 0 now, V equals to 0, that is E minus I R1. So we can write now I R1 is equals to E, that is nothing but I is equals to, this implies that I is equals to E divided by R1. So now this we can substitute in this formula now, that is here in this place, in this I am writing now E divided by R1. This is equals to 2E divided by R plus R1 plus R2. This E get cancelled. We will get now 2R1, that is 2R1 is equals to R plus R1 plus R2. Now we can have R here. So that is R is equals to, if I bring R1 plus R2 to the left side, then it will become 2R1 minus R1 minus R2. So here 2R1 minus R1 is R1 minus R2. So the resistance, the value of R is equals to R1 minus R2 when the terminal potential difference across the cells of internal resistance R1 is equals to 0. So option R1 minus R2, that is C, is the right answer. Moving to the next question, that is the IV graph for two different electrical appliances P and Q are shown in the diagram. If Rp and Rq be the resistances of the devices, then, so this is the IV graph, and Q and P, they are representing the IV characteristics. So as we know that the slope of the IV graph, is equal to the reciprocal of the resistance. So and here the slope of Q, we know that the slope of Q is greater than the slope of P, because the Q having more inclination than the P. So we can write here slope of Q is greater than slope of P. That is nothing but that is 1 by RQ is greater than 1 divided by RP. So this is clearly showing that RP, that is the resistance of the P, is greater than resistance of Q, or RQ is less than RP. So option B is the right answer. Okay, moving to the next question, that is the correct Biot-Savart's law in vector form is. We know that according to Biot-Savart's law, the magnitude of the magnetic field at a point is equals to mu naught divided by 4 pi ideal sin theta divided by r square. So now whenever we write this in the vector form, that is vector, so there must be direction, that is r cap I am writing here. R cap, which represents the direction of the magnetic field. Now this is the unit vector. This unit vector can be written as, that is r cap can be written as r vector divided by magnitude of the r. Thus we can write. Now when we substitute like this, that is r cap, this will become mu naught divided by 4 pi ideal sin theta divided by r square. In place of r cap I am writing now r vector divided by magnitude of r. So this will become now mu naught divided by 4 pi ideal sin theta, that is ideal sin theta, r vector divided by, is this r square and this magnitude r, so this will become r cube, that is dB vector is equals to this much. Now here you can see that dl, this is a current element, this is also vector current element, and r, this is sin theta. So we know that this dl cross r, so we can write here, because the sin theta we could write here mu naught divided by 4 pi ideal, that is dl cross r divided by r cube, because we know that dl cross r is equals to dl r sin theta. So we could write now dl cross r. So dB vector is equals to mu naught divided by 4 pi ideal cross r divided by r cube. So this is the correct form of Biot-Savart's law. So in this given options, we can see that the B is the correct answer. Okay, option B is the right answer. Moving to the next question, that is an electron is moving in a circle of radius r in a uniform magnetic field B. Suddenly the field is reduced to B by 2. the radius of the circular path now becomes, as we all know that radius of the circular path of the electron which is moving in the uniform magnetic field is equals to mv divided by qb. Okay. Now, they are saying that if the field is reduced by b by 2, then what will happen for the radius of the circular path? So, let me consider radius of the circular path becomes r dash when the b becomes b by 2. So, now this will become now r dash equals to 2 can be written like this 2 mv divided by qb. So, mv divided by qb already we know that is mv divided by qb is equals to r. So, we can write here 2r. So, r dash is equals to 2r. So, option B is the right answer. Okay. Moving to the next question, that is a charge q is accelerated through a potential difference V. It is then passed normally through a uniform magnetic field where it moves in a circle of radius r. The potential difference required to move it in a circle of radius 2r is. So, here a charge q is accelerated through a potential difference V. Whenever the charge is accelerated through a potential difference V, then its kinetic energy is given by, that is half mv square. Kinetic energy is equals to the charge, that is E, the potential difference, that is V. This is relation. Now, we can write V is equals to, that is velocity of the charged particle is equals to, that is V equals to square root of, 2 will come to the right side, that is 2 eV divided by m. This is the velocity of the charged particle whenever it is accelerated through a potential difference of V. Then it is passed normally. Whenever it is passed normally through a uniform magnetic field, it follows a circular path and whose radius is given by, that is r is equals to mv divided by qb, that we know. Here the radius of the circular path is directly proportional to v, that we can write, that is r is directly proportional to v. But this v is directly proportional to root, that is directly proportional to root potential difference, root v. So, directly, so by this we can write the radius is directly proportional to root v, or else v can be written as, that is potential difference is directly proportional to r square. So, here the question is the potential difference required to move it in a circle of radius 2r. So, now let me take the potential difference required, that is v dash, potential difference required to move it in a circle of radius 2r, that is 2r whole square, because v potential difference is direct proportional to r square. So, I am writing v dash is direct proportional to 2r square, that is nothing but v dash, let me take v dash divided by, v dash divided by v gives us 2r square is nothing but 4r square divided by r square. R square get cancelled, so we will get v dash is equals to 4v. So, option B is the right answer. Okay. Moving to the next question, that is a cyclotron's oscillator frequency is 10 megahertz and the operating magnetic field is 0.66 Tesla. If the radius of the disk is 60 centimeter, then the kinetic energy of the proton beam produced by the accelerator is. We know that the energy of the electron, that is energy of the charged particle in the cyclotron, is q square b square r square divided by 2m. And also we have an expression for frequency of the oscillator, that is frequency of the oscillator is equals to qb divided by 2 pi m. So, now, so let me write qb as a subject formula now, 2 pi mf. So, squaring on both the sides gives us q square b square is equals to 2 square pi square m square and f square. So, I am substituting this q square b square in the equation 1, this equation. That is the expression for the energy, kinetic energy. So, on substituting it will become, that is energy is equals to q square, that is in place of q square b square I am writing 4 pi square m square f square and r square, as it is we can write divided by 2m. Clear, this m and m get cancelled, 2 1 2 2. So, the energy can be written as 2, that is pi square m f square r square. Now, on substituting the values, that is 2 into pi square is nothing but 10, is nearly equals 10, and mass of the proton is 1.67 into 10 power minus 27 kg, and f square can be written as, that is f is equals to the frequency. Here we have 10 megahertz. 10 megahertz is nothing but 10 to the power of 7. That is 10 to the power of 7 hertz. The 7 square into r square. R square means r square, that is a 60 centimeter. That is 60 centimeter. 60 into 10 to the power of minus 2 whole square. So simplify this until we get the value, that is 2 into 10. That is 1.67 into here 10 to the power of 27 and here 10. We can write now 10 to the power of minus 26 into 10 to the power of 14 into 60 into 10 to the power of minus 1 is 6 into 10 to the power of minus 1, that is 36 into 10 to the power minus 2. Now here 2 into 36 is 72 times 1.67 into 10 to the power of minus 26 into 14. This is 14 into 10 to the power of minus 2 here, so it will become 26. This can be written as, that is E is equals to 72 into 1.67 into 10 to the power of minus 14 hertz, 14 joule. Now we have to express this in electron volt, that is energy is equals to 72 into 1.67 into 10 to the power minus 14 into electron volt. So this divided by 1.6 into 10 to the power minus 19. So on simplifying 1.6 and 1.67 nearly they get cancels, and then we will get 72 into 10 power 5 electron volt. So we could write now 7.2 into 10 to the power 6 electron volt. 10 to the power 6 is the mega electron volt, 7.2 mega electron volt. So option C is the right answer. Okay. Moving to the next question, that is, needles N1, N2 and N3 are made of a ferromagnetic, a paramagnetic and a diamagnetic substance respectively. A magnet when brought close to them will attract all three of them, attract N1 strongly, N2 weakly and repel N3 weakly. Attract N1 strongly but repel N2 and N3 weakly. So attract N1 and N2 strongly but repel N3. So here from the properties of ferromagnetic, a paramagnetic and diamagnetic substances, we know that a ferromagnetic substances, that is N1, ferromagnetic substances are strongly attracted by external magnetic field. In the same way, N2, that is a paramagnetic substances weakly attracted by external magnetic field, and diamagnetic substance, that is N3 so weakly attracted by external magnetic field. So by these properties we can see that the second option, that is attract N1 strongly, that is attracts ferromagnetic substances strongly, that is paramagnetic substances weakly, and repel diamagnetic substances weakly. So that is the right answer, that is B is the correct answer. Okay, moving to the next question, that is, the strength of the Earth's magnetic field is constant everywhere, zero everywhere, having very high value, varying from place to place on the Earth's surface. As we all know that it is experimentally estimated that the strength of the Earth's magnetic field is about 10 to the power of minus 5 Tesla, and it extends up to several kilometers. And not only that, the Earth acts as a huge magnet. So we are comparing the Earth to the bar magnet. So if you are comparing the Earth to the bar magnet, we know that the magnetic field strength will be more at the poles whereas the magnetic field at the center it is less because of less number of magnetic field lines. Here the magnetic field lines are more, so we can say they are crowded. So the magnetic field strength is more at the poles. So if you are comparing the bar magnet with the earth or earth to the bar magnet, it is clearly showing that the earth will not be having the same magnetic field strength at every places. So it is varying from place to place on the surface of the earth. So option D is the right answer for this question. Okay. Moving to the next question, that is a jet plane having a wing span of 25 meter is traveling horizontally towards east with a speed of 3600 km per hour. If the Earth's magnetic field at the location is 4 into 10 to the power minus 4 Tesla and the angle of the dip is 30 degree, then the potential difference between the ends of the wing is. Here a jet plane is moving in the direction of east. This is the direction of jet. So, the direction of motion of the jet plane, and then wings of the jet plane is going to cut the magnetic field lines which are acting in this direction, and here we have the angle of dip, that is 30 degree, and the magnetic field we have here magnetic field 4 into 10 to the power minus 4 Tesla, and we know that, let me consider, this is the vertical component of the magnetic field, that is B sin theta, and this is motion of the jet plane in this direction, so which cuts the magnetic field lines. So EMF will be induced in the wings of the jet plane. So EMF induced is considered as motional EMF. That motional EMF is given by the equation, that is BLV sin theta. BLV sin theta. This is the B sin theta is the vertical component of the magnetic field. L is the length of the wing span and V is the velocity of the jet. So on substituting the values, that is B equals to 4 into 10 to the power minus 4, and L, that is the length 25 meter, and velocity is 3600, that is 3600 kilometer per hour. This can be written as 3600 into 5 by 18 meter per second. So this is 18 1 ja 18 200, that is 200 into 5 is 1000 meter per second. So here V is 1000 meter per second, and sin theta sin 30. So I'm simplifying, that is sin 30 is 1 by 2. So this 1 by 2 into 4 is 2. 2 into 25. That is 2 into 25 is 50. 50 into 10 to the power minus 4 and 10 to the power minus 3. This will become 10 to the power minus 1. So this is equals to 5 volt. So option B is the right answer. Moving to the next question, that is, which of the following represents the variation of inductive reactance XL with the frequency of voltage source V? Here V is the frequency and XL is the inductive reactance, and this graph showing the linear relationship, that is, by this graph we can write XL is directly proportional to frequency, and here this graph representing the top opening parabola. For top opening parabola we have equation, that is y is directly proportional to v square, that is nu square, frequency square. This is a relation. Next here this graph represents the relation like this, that is XL is, this is top opening parabola. For top opening parabola we can write root v. For this type of curve we will get the y equals to root x. So therefore we can, and for this graph, so that is XL is inversely proportional to V. But they are asking you to find out variation of inductive reactance with the frequency. Now let me check the inductive reactance and the frequency relation. The inductive reactance is equals to omega L, as we know that. And then here inductive reactance is equals to 2 pi FL. You can write now 2 pi FL because omega is 2 pi F. So by this we can write XL, that is inductive reactance, is directly proportional to F, as well as inductive reactance is directly proportional to its inductance. So here we need to find out the variation of inductive reactance with the frequency. So here this XL is directly proportional to F. So directly proportional to F means here XL is directly proportional to V. So this graph represents the variation of inductive reactance with the frequency of voltage source. So option A is the right answer. Moving to the next question, that is the magnetic flux linked with the coil varies as I equals to 3t square plus 4t plus 9. The magnitude of the EMF induced at t equals to 2 seconds is, we know that the magnitude of induced EMF from the Faraday's laws, we can write that is E equals to d psi by dt, that is rate of change of magnetic flux, gives us the magnitude of induced EMF. So this is equals to now d divided by dt, and here I am writing the psi value, that is 3t square plus 4t plus 9. So now on simplifying, on differentiating this 3t square plus 4t plus 9, we will get 6t plus 4, that is EMF induced in the time, that is equals to 6t plus 4. So at t equals to 2 second, 2 equals to 2 second, 6 into 2 is 12, 12 plus 4 is 16. So E is equals to 16 volt. So option B is the right answer. Okay, moving to the next question, that is a 100-watt bulb is connected to an AC source of 220 volt 50 hertz. Then the current flowing through the bulb is, so we know that power of the bulb is equals to voltage times the current. So current is equals to P by power divided by voltage, that is power of the bulb is 100 watt divided by voltage is 220, that is 220. 0 0 get cancelled, 10 divided by 22 is nothing but 5 by 11, it is 5 by 11 ampere. So option A is the right answer. Okay, moving to the next problem. In the series LCR circuit, the power dissipation is through R, L, C, both L and C. So as we know that the power dissipation in the LCR circuit, series LCR circuit, is equals to Vrms Irms times cos I, that is power factor. So we know that cos I is equals to, that is power factor, is equals to R by Z, as well as Vrms can be written as, that is Vrms can be written as Irms times impedance, that is Z. So on substituting these two in this, we can get power dissipation is equals to Vrms. In place of Vrms, I am writing Irms into Z, and in place of Irms, as it is, I'll write Irms, and cos I equals to R by Z. So Z and Z get cancels, we will get Irms square, that is Irms square times R. So by this we can say that power is directly proportional to, that is power dissipation is directly proportional to R, that is power dissipation is through only resistance. So option A is the right answer. Moving to the next question, that is in Karnataka, the normal domestic power supply AC is 220 volt 50 hertz. Here 220 volt and 50 hertz refers to, as we know that AC is represented by sinusoidal voltage, sinusoidal wave, this. So this is having a frequency, so that is much 50 hertz. So 50 hertz representing frequency. Next, this is a peak value of the voltage, this is peak value, and we need to consider all the voltages, that is instantaneous voltages. So the square root of the mean of all the squares of instantaneous voltages is considered as RMS value of voltage or RMS value of current. This RMS value of voltage is nothing but the square root of mean of the squares of all the instantaneous voltages of the AC wave. So the given value, that is 220 volt, is always assumed to be RMS value. So option B is the right answer, that is RMS value of the voltage and frequency. 220 volt is nothing but RMS value of the voltage and 50 hertz is frequency. So option B is the right answer. So moving to the next question, that is a step up transformer operates on a 230 volt line and high load current of 2 ampere. The ratio of primary and secondary windings is 1:25. then the current in the primary is. So, we know that the turn ratio in the transformer is Ns by Np is equals to Ip by Is, Ip by Is. So, here we have Ns by Np, that is here we have a ratio of primary, and that is Np is to Ns is equals to how much? 1 is to 25. This is nothing but Ns is 25 times and Np is 1 time. So, Ns 25, Np is 1 time. This is equals to Ip divided by Is. Ip divided by Is is, that is load current, that is 2 ampere. So, just you cross multiply, you will get Ip, that is current in the primary coil, that is Ip equals to 50 ampere. So, option B is the right answer. Okay. Moving to the next question, that is the number of photons falling per second on a completely darkened plate to produce a force of 6.62 into 10 to the power minus 5 Newton is n. If the wavelength of the light falling is 5 into 10 to the power minus 7 meter, then n is equals to dash into 10 to the power 22. And as we know that energy of the each photon is equals to hc divided by lambda. If there are number of photons, we can write n, number of photons hc divided by lambda. Now let me write E divided by T will become power, that is n number of photons per second hc divided by lambda. We could write now this number of photons per second, according to them it is n hc divided by lambda, and E divided by T is nothing but P. Now power can be written as force into velocity. The C is velocity of light, that is n hc divided by lambda, and this C get cancelled. So we will get now n is equals to f lambda divided by h. So on substituting these values, that is n is equals to, that is number of photons per second is equals to f, here we have f, that is 6.62 into 10 power minus 5 Newton into lambda. So here we have lambda, that is 5 into 10 power minus 7 divided by h, that is 6.62 into 10 power minus 34. So here 6.62 get cancels, and then here we have only 5 into 10 to the power minus 5 into 10 to the power minus 7, 10 to the power minus 12, 10 to the power minus 12 divided by 10 to the power minus 34 is 10 to the power 22. This is number of photons per second. So 5 into 10 to the power 22. Here n equals to 5 into 10 to the power minus 2. So 10 to the power 22. So option B is the right answer. Okay. Let's have a look at the next question, that is an object is placed at the principal focus of a convex mirror. The image will be at, so here this is the convex mirror. We know that the focus of the convex mirror, where will the focus of the convex, this is the convex mirror, and focus of the convex mirror is here. This is the focus. If you place any object at the focus, we won't get any image, because you are placing the object the back of the reflecting surface. If you want to get the image, the object must be placed in front of the reflecting surface, then only image will be obtained. But here in the question, the object is placed at the principal focus. If you place here, then we won't get any image. Okay. So option D is the right answer, that is no image will be formed when we place the object at the principal focus of the convex mirror. Okay. Moving to the next question, that is an object is placed at a distance of 20 centimeter from the pole of a concave mirror of focal length 10 centimeter. The distance of the image formed is, see here is concave mirror it is. So for concave mirror the focal length is negative. So here f is equals to negative focal length 10 centimeter, and the object distance is minus 20. According to Cartesian sign convention, should be taken as negative. So from the mirror equation we can write 1 by f is equals to 1 by v plus 1 by u. So on substituting the values, that is 1 by f, that is 1 by minus 10 is equals to 1 by v plus 1 by minus 20. So this will become, on substituting, it will becoming now, it will become 1 by V is equals to 1 by 20 minus 1 by 10. So this can be written as 20, now 1 minus 2. So this can be written as minus 1 by 20. 1 by V is equals to minus 1 by 20. So we could write that V equals to minus 20 centimeter. V, that is image distance, is the distance of the image formed is 20 centimeter on the same side of the mirror. So option C is the right answer. Okay, moving to the next question, that is a candle placed 25 centimeter from a lens forms an image on a screen placed 75 centimeter on the other side of the lens. The focal length and the type of the lens should be. So here there is a lens, let me consider this is a lens, and the candle is placed, let me consider this is a candle at a 25 centimeter, that is U, object distance is 25 centimeter, and image is formed on the other side of the, so let me consider this is the image which is formed, so object, let me consider this is image is formed on the other side of the lens, so this is image distance. Okay, according to Cartesian sign conventions, the object distance should be considered as negative, that is U equals to minus 25 centimeter, minus 25 centimeter, and image distance, it should be taken as positive because here it is formed on the other side. According to Cartesian sign conventions, we can take this one as positive, that is 75 centimeter. Now from the thin lens formula, we know that 1 by F is equals to 1 by V minus 1 by U, and substituting the given values, that is 1 by V equals to 75 minus 1 divided by U is minus 25. So this becomes now 75, on taking LCM we will get, so minus 1 minus, it will become plus, so it will become now 75 1 plus 3. So this is becoming now 4 by 75, that is 1 by F is equals to 4 by 75, that is F. So F can be written as 75 divided by 4. So 75 divided by 4 is nothing but 18.75, that is plus 18.75 centimeter. So plus 18.75 centimeter. So option A is the right answer, plus 18.75 centimeter, and it is convex lens. We know that if the focal length is positive, it is convex, lens. And if it is negative, then it is concave lens. Okay, so option A is the right answer. Okay, let me continue my discussion in the next session. Okay, thank you, thanks for watching.